Hello, what we're looking at is exponential functions, and you see some examples of them. The key is there's a variable in the exponent. If you looked at the introduction where I did this, okay, what we noticed is there was a variable in the exponent. Now in the past we haven't had variables in the exponents. We've dealt with variables like here, right? But we have not ever dealt with a variable in the exponent, and that's the new thing, why it's called an exponential function. Now some of these you can solve. The first one, we'll look at this, 2 to the x equals 8. So it's like saying y is equal to 8, right? 2 to the x equals 8. Something like that you can solve using a strategy of common bases, and you'll see that come up. We know that 8 could be 2 cubed, right? Because 2 times 2 times 2 is 8. And we could say, well, hold on, if the bases are the same, we can ignore the bases, and that's what it's talking about in this slide. If ax equals ay, then x equals y. We could ignore the bases and say, well, x must equal 3, because that's the only way that would be true. Now that works out nicely for that one. Right? It also works out nicely for the next one, where we could say 3, it looks like x minus 5 is equal to, hang on, I gotta see this, 1 over 9. Sorry, that's an a, pardon me. 1 over 9. Well, but couldn't we say that 1 over 9 is 1 over 3 squared? But couldn't we say that 1 over 3 squared is 3 to the negative 2? Right? And then that one works out quite nicely. Because our bases are both 3, we can make our exponents match. A minus 5 equals negative 2, and therefore a must equal 3, right? 3. And that would make sense, that would be true. Now, the problem is we have to have 2 and 8 so that we can get a common base. The other one there, 5 to the 2 minus 1 equals 6 to the y plus 4. Okay, that's not going to work so well. See, these are kind of special cases if we set them up properly. 2 cubed is 8, that's nice. You know, 3 and 3, that's nice. But what happens when we have 5 and 6 as a base? Right? We're not going to be able to line those up with common bases. And this is the type of thing that we will need logarithms for. Okay, so we're going to keep going. It's a bunch of slides on this stuff, and then we'll get into the logarithms. But there's a difference between why these work and why we need logarithms for some of the other things.